Well, students, in PUC, in the last class, has given homework for aldol condensation between the acetaldehyde and the propion aldehyde. So here, three types of condensations are possible. One is between the acetaldehyde molecule, between the propion aldehyde molecule, between ethanol and propanol, then propanol and ethanol. We know in aldol condensation there must be alpha hydrogen atom. So here we have alpha hydrogen, 3 alpha hydrogen, here we have 3 alpha hydrogen atom. So one hydrogen atom attached to this one, then carbon links to this, so you are getting this product. The name of this compound is, you can name this one as, it's a 1, 2, 3, 4. The name of this compound is, it is 3-hydroxy. 3-hydroxy methyl prop but, so butanol. 3-hydroxy butanol, and we know this one 2, 3, 4. It is butan, but 2en, 1r. For this one, between the two molecules of propanol, we have, so it's the first carbon, second, third, fourth and fifth. The name of this compound is 3-hydroxy. 3-hydroxy, then 3, 2 methyl, 2-methyl pentanol, pentan, 1-R pentanol. The name of the next product, which is formed after the elimination of water, it's a 1, 2, 3, 4, 5. So it's an alpha beta elimination. We know this is alpha carbon, this is beta carbon. That means elimination must take place between these two, not between these two. Alpha, beta. CHO, adjacent carbon is alpha. So alpha carbon, then beta carbon. Elimination of H2 takes place between these two, OH and H. So you are getting this product. The name of this one is, it is 2-methyl pentan, pent, 2en, 1r. Well, the name of this one again is 1, 2, 3, 4. 3-hydroxy, 3-hydroxy, then it's a 2-methyl, 3-hydroxy, 2-methyl, butan, 1R, or simply you can write butanol. And again, elimination takes place between alpha and beta carbon. So this one is the alpha, adjacent to functional group CHO alpha. So alpha and beta carbon, the name of the product is 1, 2, 3, 4. So it is 2-methyl, then but 2en, but 2en, 1r. Similarly, for this one here, the name of the product condensation takes place between the alpha carbon and the linking takes place between the alpha carbon and the functional group carbon, C double bond carbon. Side become, now it is 1, 2, 3, 4, 5. So total 5 carbon, so 3-hydroxy, 3-hydroxy pentanol, or you can write pentan, 1R. No need, it implies that CHO, first carbon itself is a CHO. So you can write pentanol also. Now the name of the product again, alpha beta. Alpha beta, 1, 2, 3, 4, 5. Name of this compound is pent, 2en, 1R. So I think all of you have completed the homework. Well, afterwards you are studied Cannizzaro reaction. In Cannizzaro reaction, aldehyde not containing alpha hydrogen. That's important here. There must be alpha hydrogen. There must be no alpha hydrogen. Aldehyde not containing alpha hydrogen undergo condensation in presence of strong alkali like NaOH or KOH to give the product, that is a reduced and oxidation product. You are getting alcohol as a reduced product and oxidation product as the carboxylate ion or sodium or potassium salt of carboxylic acid. So that you are studying. In the Cannizzaro reaction, what you have to remember is simultaneous oxidation and reduction takes place. Oxidation product is carboxylate ion and reduced product is alcohol. Then you are studied the electrophilic substitution reaction of benzaldehyde. We know carbonyl group or the C double bond, it may be aldehydic or it may be ketonic benzaldehyde. This group is metadirectic. So remember this one, it's metadirectic or deactivating group. Well, so benzaldehyde undergo nitration with concentrated HNO3 in presence of concentrated H2SO4. So you are using a mixture called nitrating mixture. So this on heating, you are getting meta product, metanitrobenzaldehyde. So this one is metanitrobenzaldehyde is the product. So this is about the preparation and properties of aldehydes and ketones. Then uses of some important aldehydes. For example, uses of formaldehyde. Formaldehyde is used in the manufacture of urotropin and antiseptic. That's called urinary antiseptic. So that on nitration, you are getting the nitro product and that nitro product is explosive. Afterwards, formaldehyde is also used in the manufacture of polymer, a bakelite, strong plastic, and that bakelite is obtained by the polymerization of formaldehyde with the phenol. So phenol formaldehyde polymer is bakelite. It's a strong polymer or a strong plastic. Then the formaldehyde, about 40% remaining is water and some alcohol. So 40% aqueous solution of formaldehyde is called formalin, and formalin is used to preserve biological specimens. So the bottle containing the specimens in the biology laboratory that contains the solution as a formalin, not water, it is formalin. It is used to preserve biological specimens. Acetaldehyde is used in the silvering mirror because we know aldehyde when react with its tolerance reagent, you are getting silver mirror, and that property is used in silvering the mirror or the acetaldehyde. It is also used in the preparation of paraldehyde and metaldehyde. Acetaldehyde is also used in the preparation of carboxylic acid. Afterwards, benzaldehyde. Benzaldehyde is used in perfumes and also as essence. Well, then about this acetone, one of the main application of acetone, it's used as solvent for many organic reactions. Okay, it's also used in the preparation of some organic compounds like it's chloroform and iodoform, etc. Then about acetophenone. Acetophenone is having a pleasant smell. It's used in perfumes. Well, this is about aldehydes and ketones. The next part is carboxylic acid. So what are carboxylic acid? We know the carboxylic group COOH. Whenever there is COH group in an organic compound, Such a compounds are called carboxylic acid. There may be some other group like OH, etc., whatever it may be. According to priority order, by naming, you are naming as the carboxylic acid itself. So it is the carboxylic acids are organic compound containing carboxylic or COOH group. Now about nomenclature, as we know, organic compounds are named by two ways. One is a trivial system and another is IUPAC system. And again we know generally trivial system is based on the source. So it is based on the source. Many of the carboxylic acids are named based on the source. For example, distillation of red ant gives the acid, and that acid is called formic acid. So formic acid name is derived from Latin formica. Formica means ant. Then acetic acid. Acetic acid, it is also derived from the Latin word. So it is acetum. Acetum is nothing but vinegar. It is the component of vinegar, main component of vinegar. So this acid is called acetic acid. Afterwards, we have many caproic acid. Then we have the butyric acid. That acid is again derived from the Latin word butter. So it is called butyric acid. So important is IUPAC nomenclature. And again we know in the IUPAC nomenclature, first you have to see the suffix and how to number the carbon chain. ಅಂದರೆ ಈ nomenclature ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಹೆಸರು ಬರಿಬೇಕಾದರೆ ಅಥವಾ ಹೇಳಬೇಕಾದ್ರೆ ಎರಡು ಸಿಸ್ಟಮ್ ಇದ್ದಾವೆ. ಒಂದು ಟ್ರಿವಲ್ ಅಥವಾ ಕಾಮನ್ ಆಗಿ ಹೇಳೋದು, ಇನ್ನೊಂದು IUPAC. ಕಾಮನ್ ಸಿಸ್ಟಮ್ ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ, ಯಾಕಂದರೆ ಯು ಕೆನಾಟ್ ರೈಟ್ ದಿ ನೇಮ್ ಆಫ್ ಆಲ್ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಎಲ್ಲ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಹೆಸರು ಬರಲಿಕ್ಕಾಗಲ್ಲ ಕಾಮನ್ ಸಿಸ್ಟಮ್ನಲ್ಲಿ. ಹಂಗೆ IUPAC ಇಂಪಾರ್ಟೆಂಟ್. ಕಾಮನ್ ಸಿಸ್ಟಮ್ ಯಾವುದರಿಂದ ಬಂತು? ಕಾಮನ್ ಸಿಸ್ಟಮ್ ನಾವು ಆ ಆಸಿಡ್ ಯಾವುದರಿಂದ ಪಡೆಯುತ್ತೇವೆ ಅದರಿಂದ ಬರುತ್ತೆ. ಎಕ್ಸಾಂಪಲ್ ಆ್ಯಂಟ್, ಕೆಂಪು ಕಲರ್ ಆ್ಯಂಟ್ ಅಂದರೆ ಇರುವೆ, ಅದನ್ನು ಬಟ್ಟಿ ಇಳಿಸಿದಾಗ ಅಥವಾ ಡಿಸ್ಟಿಲೇಷನ್ ಮಾಡಿದಾಗ ಅದರಿಂದ ನಮಗೊಂದು ಆಸಿಡ್ ಉತ್ಪತ್ತಿ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್ ಅಂತ ಹೇಳಿದ್ರು. ಯಾಕೆ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್? ಯಾಕಂದರೆ ಲ್ಯಾಟಿನ್ ಫಾರ್ಮಿಕಾ, ಲ್ಯಾಟಿನ್ ವರ್ಡ್ದು ಫಾರ್ಮಿಕಾ ಅಂದರೆ ಇಂಗ್ಲೀಷ್ನಲ್ಲಿ ಆ್ಯಂಟ್. ಹಾಗಾಗಿ ಅದರಿಂದ ಬಂದಂಥ ಆಸಿಡ್ಗೆ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್ ಲ್ಯಾಟಿನ್ ವರ್ಡ್ನಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಅದೇ ಟೈಪ್ ಎಸ್ಟಿಕ್ ಆಸಿಡ್. ನಿಮ್ಗೆ ಗೊತ್ತುಂಟು ವಿನೆಗಾರ್ ಒನ್ ಆಫ್ ದ ಮೇನ್ ಸಾರಿಂಗ್ ಏಜೆಂಟ್. ಅಂದರೆ ಹುಳಿ ಇರಬೇಕಾದ್ರೆ ವಿನೆಗಾರ್ ಬೇಕಾಗುತ್ತೆ. ವಿನೆಗಾರ್ಗೆ ಲ್ಯಾಟಿನ್ದಲ್ಲಿ ಅಸೆಟಮ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಇಂಗ್ಲೀಷ್ ವರ್ಡ್ ವಿನೆಗಾರ್, ಅದಕ್ಕೆ ಅಸೆಟಮ್. ಹಾಗಾಗಿ ಆ ಲ್ಯಾಟಿನ್ ಹೆಸರಿಂದ ಅದಕ್ಕೆ ಎಸ್ಟಿಕ್ ಆಸಿಡ್ ಬರುತ್ತೆ. ಅದೇ ಟೈಪ್ ಬಟರ್ ಗೊತ್ತುಂಟು, ಹಾಲಿಗೆ ಸಿಗುತ್ತೆ. ಆ ಬಟರ್ದಲ್ಲಿರುವಂಥ ಆಸಿಡ್ ಬ್ಯೂಟರಿಕ್ ಆಸಿಡ್. ಸೊ ಬಟರ್, ಬ್ಯೂಟರಿಕ್ ಆಸಿಡ್ ಇವೆಲ್ಲ ಲ್ಯಾಟಿನ್ ವರ್ಡಿಂದ ಬಂದಂಥ ನೇಮು. ಇವೆಲ್ಲ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್? ಸೋರ್ಸ್ ಯಾವುದರಿಂದ ಸಿಕ್ತು ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಯಿತು. ಈಗ IUPAC ನೋಮೆನ್ಕ್ಲೇಚರ್ದಲ್ಲಿ ಏನು ಮಾಡ್ತೇವೆ? IUPAC ನೋಮೆನ್ಕ್ಲೇಚರ್ದಲ್ಲಿ ನಾವು ಗೊತ್ತುಂಟು ನಿಮಗೆ, ಅಕಾರ್ಡಿಂಗ್ ಟು ಪ್ರಯಾರಿಟಿ ಆರ್ಡರ್ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಫಸ್ಟ್, COH ಗ್ರೂಪ್ಗೆ ಪ್ರಯಾರಿಟಿ ಫಸ್ಟ್, ಆಮೇಲೆ ಉಳಿದೋ ಬರುತ್ತೆ SO3H, ದೆನ್ COR, ದೆನ್ ಇಟ್ಸ್ CN, afterwards aldehyde, ketones, then alcoholic, then it's triple bond, NH2, triple bond, double bond, triple bond, ಈ ಟೈಪ್ ಬರುತ್ತೆ. You know this one. So in the IUPAC system, first one is what is suffix? Suffix ಯಾವುದು? Then selection of a long chain, and afterwards writing the substitute. So let us discuss about carboxylic acid. ಈ ಟಾಪಿಕ್ ಮೇಲೆ ಸ್ವಲ್ಪ ಡಿಸ್ಕಷನ್ ಮಾಡೋಣ. ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಸೊ So organic compound containing organic compounds containing COOH group are called carboxylic acids. Nomenclature. So nomenclature, we have common system or trivial system based on source, generally based on source. And in IUPAC, so you must know the suffix and number in the carbon. Suffix is oic acid. Suffix is oic acid. So directly I am writing the formula, then trivial name or common name and IUPAC name. So important is IUPAC nomenclature. So formula, then so common or trivial name, then IUPAC. Well, first one is HCOOH. HC double bond OH. It is called formic acid. Then next CH3, COOH. Afterwards CH3, CH2, COOH. Then the CH3, CH2, CH2, COOH. And afterwards we have CH3, CH3, COOH. So next one is, it is COOH, COOH. Then it is COOH, CH2, COOH. Then COOH, CH2 twice, COOH. So then we have COOH, CH2 thrice, COOH. Then we have COOH, I am writing here CH2 4 times instead of wasting the time here. Just you have to remember IUPAC. Then we have COOH. COOH. Well, now first one is formic acid. Next we know it's called acetic acid. Next, propionic acid. Propionic acid. Propionic acid. Propionic acid. Then butyric acid. Then we have this group is called iso. We know CH attached to 2CH3 iso. So it's isobutyric acid. Isobutyric acid. Then we know this is called oxalic acid. Then malic acid. Then succinic acid. Succinic acid. Then adipic acid. Remember this one. Then we know this is called benzoic acid. And afterwards, this is called tannic acid. Tannic acid. So these are the common: formic acid, acetic acid, then propionic acid, afterwards butyric acid, isobutyric acid, Ohm's gap ಅಂತ ಹೇಳ್ತೇವೆ. It's oxalic, malic, succinic and adipic acid. Afterwards, we know this one is benzoic acid and this one is tannic acid. Now in IUPAC system, as we know, first you should know the suffix. Suffix for carboxylic acid is oic acid. Number of carbon atoms are 1. So it is methanoic acid. Methanoic acid. Next one is number of carbon atoms are 2. So it is ethanoic acid. Ethanoic acid. Number of carbon atoms are 3. So it is propanoic acid. Propane. Yeah, white acid. Propanoic acid. Here this one is propionic acid. This one is propanoic acid. It is number of carbon atoms are 4. So it is butanoic acid. Butanoic acid. Number of carbon atoms are 4, but we have it's a CH3 group on the side chain. It's a 1, 2, 3. The name of this compound is 2-methyl propanoic acid. Propanoic acid. Now we have a dicarboxylic acid. So it is a dicarboxylic acid 1 and 2. So it is ethane dicarboxylic acid or ethane dioic acid. Ethane dioic acid. Ethane dioic acid. And this one is propane dioic acid. So there must be COH group on the terminal carbon. No need to number 1, 2, 3. So it is propane dioic acid. Propane dioic acid. This one is again total number of carbon atom are 4. So butane dioic acid. Butane dioic acid. Then total number of carbon atom are 6. So it's hexane dioic acid. Hexane dioic acid. Afterwards, so it's also called benzoic acid or benzene carboxylic acid. So it's a benzoic acid. Common name is also benzoic acid. Vinylic acid also benzoic acid. Benzoic acid or benzene, it's a carboxylic acid. Now this one is 1 and 2. On the first carbon and second carbon we have COH group. So it's a benzene 1, 2 dicarboxylic acid. Now these carbons are not considered. Here these carbons are considered. So dioic acid. But these carbons are not considered here. So it is a dicarboxylic acid. It's a benzene 1, 2 dicarboxylic acid. Dicarboxylic acid. So in this way we can name the carboxylic acid. Now about preparation. So I think you are followed here. Oic acid is the suffix for the carboxylic acid. 1 carbon methanoic acid, 2 ethanoic acid, 3 carbon propanoic acid, 4 carbon butane butanoic acid, again 4 carbon, but we have a side chain in case of the IUPAC system. We have to number it. On the second carbon we have methyl, so 2 methyl propanoic acid. Now 2 carboxyl groups are there, it's 1 and 2. So ethane dioic acid, no need to write the number because COH group always on the terminal carbon. We have 3 carbon, so it's propane dioic acid. It is succinic acid is the common name. Number of carbon are 4. Butane dioic acid, 6 carbon hexane dioic acid, and we know this is called benzoic acid or benzene carboxylic acid, and we know this one is benzene 1, 2. This is first carbon. This one is second. So it's a benzene 1, 2 dicarboxylic acid. Now it's about the preparation of carboxylic acids. Well, the carboxylic acids can be prepared from alcohol and aldehydes. So we know primary alcohol on oxidation gives aldehyde, which on further oxidation gives the carboxylic acid. So aldehyde and carboxylic acid contain same number of carbon atoms as there are in the alcohol. Second method, it is from cyanide or nitrite. We know hydrolysis of nitrite gives amide, and that amide on further hydrolysis just by heating gives the carboxylic acid. So this is the second method. And third method, it is from carbon dioxide. So all these methods are important. We can discuss this in the next video.